Okay, not sure if any. Hello, everyone. Hi, Vasa. How are you doing today? Not sure if I was audible before now. So while you're here, don't forget to check in. You can check in using the link on the comment section, and also you can check in use the QR code on the screen right here. While we can wait for more people to join, maybe in the next few minutes. How are you? What's happening? Uh, yeah. Good morning, good afternoon, good evening, wherever you're tuning in from. And tell me what's happening on your end. What's up? Hi, Pujan. Hello. What's happening on your end? How is the weather? Is it morning? Is it afternoon? Is it evening? What's going on? And how have your day been? And don't forget to check in using the link on the comment section. And you can also check in using the QR code. And just curious, how if you're on the screen, if you're here right now, I want to know if you joined my last stream. So this stream is going to be like a practical stream for what we did last time. It's 3 p.m. and it's cloudy in Nepal. Okay. It's still a.m. my time. It's like 11 a.m. A little bit sunny down here. I see. Very hot. David. David, where are you tuning from? Adeinka. So how many of you were in my last stream where we talked about why big infrastructures fail? Yeah, Nigeria. We're in Nigeria. I'm in New York. Let me guess, Lagos. Oh, okay. Kusi did not join my last stream. No issues. So this is like a continuation of the last stream. It's not a continuation. It's a whole different stream. So the last stream was literally why big infrastructures fail, right? So like, and how we can actually build systems that are resilient to failure. That was our last stream. Okay. People 3 p.m. India time. The weather, let's say, a little cloudy. Okay. I think Lagos. How is Lagos today? Okay, so the last stream was more of theoretical. We explained basically everything we're going to come across again right here, right? But then we actually get our hands dirty, like doing these things we talked about. So last stream was a deep dive. We actually deep dive into what this is. The auto scaling, load balancing, DNS. We actually look at it in the last stream, so you can check that stream. You can check it out later on. If you want to get like a whole overview of the what these things are. But today we also discuss a little bit of what they are, which we will do just a little bit, but we're not going to dive into it. So we focus more on the practical aspect of it using AWS. Yeah, so that's literally what we're going to do on this stream. So it's going to be a 1.5 hour stream. So we're going to get busy. So I'm just going to scan through the theoretical explanations of, these concepts, and we will dive deep into using AWS. So if you don't have an AWS account, you can just go ahead and sign in, get a free account on amazon.com/free. I just dropped the link on the comment section right there. So if you don't have a free account, you can get a free account. I dropped the link also on the Discord when I announced the stream. So you can actually, like 30 minutes ago, you could have signed up, get an account. But if you don't, you have the time to do that also now. So you can go ahead and sign up for a free account. I believe they give you 200 USD credit. I believe so. Yeah, 200 USD credit for you to experiment and use on the platform. So you have access to free trial that you can use the free credit for. They may ask you for a credit card for you know for registration just to make sure you're not a robot and so forth. I think a lot of platform does that. So it's just for verification, but you're not gonna get charged for everything we're going to do on this demo. So if you have a free account, the free credit they give you, you can use that for this demo. So just before I go ahead, how many of you have AWS account? How many of you have signed up? If you don't have, I just want to know. And I think the question is, how many of you don't have an AWS account? Yeah, let me know who doesn't, and if they're having any difficulties, getting an AWS account, like try to sign up and all that. So let me know on the comment section if you don't have an AWS account, and if you're having issues trying to sign up. People say it's 3 p.m. Indian time. Okay, the weather is cloudy. Hey, forgive me if I pronounce that wrongly. So it's running here in Himalaya, India. Okay, I think it rained right down here yesterday, but today is all sunny. So if you don't have an AWS account, go ahead and sign up one. Okay, so no one has indicated that they don't have. So I'm assuming everyone on the stream has an AWS account. Is that correct? If you don't have an AWS account, let me know on the comment section. I want to be sure that we are ready. Okay. So we actually want to take a look at what actually happens, like behind the scene when we deploy our applications, right? No, I don't have. Okay, so I see comments. I don't have an AWS account. Okay, so you can sign up with the link I shared. So you can just go to the link aws.amazon.com/free and sign up for a free account. And let me know if you have any issue while doing that. So you can go ahead and sign up for one. I see K4 say, yeah, I have one, but I'm having trouble getting the verification code. Oh, I'm being limited to use some services because of this. So the verification code should basically come to your email address. So when you request for code, like what happens, like what difficulties are you having exactly? Yeah, I mean, it will limit you to some services, but I'm not sure if, I don't know, are you able to create EC2, like virtual machines? Literally, that's basically what we'll be doing today, creating VPCs, virtual machines, auto scaling groups, and load balancers. That's literally what we'll be doing. So I'm not sure which services you're limited to at the moment, but yeah, I mean, we'll get to that. But then when you mention you're having trouble getting the verification code, what's happening exactly? Like when you click to verify, they're supposed to send you a code via your email, or phone number, or your authenticator app. Not sure exactly where you're stuck with the verification. Okay, well, still on the screen. If you don't have, just sign up for free accounts, and you should be good to go like in a few minutes. Okay, so I have a question for everyone on the stream. So like when it comes to when you build an application, you must have deployed an application, right? So the question is, have you deployed an application before? If you have, just let me know in the comment section what you deployed and which platform you used to deploy the application. I just want to know. Just tell me in the comment section, what you build and deploy. Like, okay, you build something, you deploy with Netlify. I think it's very popular. People use Netlify a lot to deploy application these days. So let me know which platform you've used to deploy in the past. Maybe AWS, maybe Google, Azure, whichever the platforms you have used to deploy applications. Yeah, Versa. Okay, so I might say deploy a Nest.js application with Versa. Yeah, so very popular platform used to deploy uh, Node Node.js applications. Okay, and just a follow-up question to you. I believe it's very easy to deploy. Did you have issues deploying? And okay, so David used Jenkins and DigitalOcean. Oh, I see. So he used Jenkins, which is a CI/CD tool, and he deployed in DigitalOcean. Cool. Okay, Kofi deployed to Render. Yeah, Render. Yeah, I used Render before to deploy a Node.js application. Yeah, very cool interface too. Like very easy. Okay, Beep used GitHub pages and deployed to Verse. Cool. Yeah. So the question is, what happens behind the scene? You may be asking, which is what we're trying to figure out in this, in this stream, right? Developer perspective versus actual process. So when you, at most of these platform mentions makes it very easy to deploy. In when you compare them to, I mean, AWS, Azure, Google, they also have services that helps you deploy easily, right? Like they have app services. Sorry, so Azure app services that helps you deploy applications. Like is a pass, is a platform as a service, so you just deploy. Like you don't worry about the infrastructure. You just select what you want and so forth, and it just deploys. You can just connect to they also have Elastic Beanstalk for AWS. Which other one? App Runner. So they also all the services have all these platforms or services within them that helps you deploy without worrying about what is going on behind the scene, right? So you can just quickly deploy and everybody's fine. Pujan says, I'm a professional software engineer and deployed both in AWS and DigitalOcean. Use CDN and RATS 5.3 services. Yeah, cool. So I use Netlify, but I think it only supports front-end apps. Yes, it does. I think there's a trick some people use to deploy Node.js backend in Netlify these days. Yeah, not sure. So, anyways, so most people don't really, you know, focus on what happened behind the scene. Like what actually happens when you click deploy, right? So it could be very easy. Literally, it should be easy, yeah. But there could be a time it gets complicated depending on the infrastructure you're trying to build, which is what we'll be focusing today, right? So last stream was more of building an infrastructure, that is resilient to failure, because we can actually 100% remove failure. Systems will fail, big infrastructures fail. Big cloud platforms like AWS, Google Cloud, they all fail sometimes. Sometimes they are done. So we can't actually 100% have no failure. But we're trying to see if we can build a infrastructure that actually can withstand and fall back on time when there's failure. So, which is basically what we're going to do. We're going to see how we can actually build all those things together. Just think, okay, if this happens, what happens next, and so forth. So let's see. I'm going to share a link right now on the chat. It's just a Google Gemini playbook of literally everything we'll be doing today. So if you take a look at that link, it gives you like an overview and step-by-step instructions of what you're going to do today. It also has a link to, let me see if I can open it right here on the screen. It should be here. Here we go. Okay, so this is it. So this is what the page looks like. So it literally gives you step-by-step instructions or phases of everything we'll be doing today. Like from page 1 to the last things we'll be doing. So for each one you finish, you can just check this. It's not writing anything back. It's just a UI, so nothing is recording, no database. But it just gives instructions of everything we'll be doing, and you can follow along right here, and you can also follow along on what I will be doing on the screen. Uh, this is the link to the GitHub scripts right here. So if you click on that link, it should take you to the GitHub scripts. Some of the scripts we'll be using throughout the stream are already there, so you can just copy and paste it, on your end while following the demo. So the link on the comment section, you can actually have like a clear of the steps being followed. Okay, so again, I want us to dive into exactly what we'll be doing. So we'll be creating infrastructure, that can actually, on its own, heal, when something goes wrong. So we're gonna spin up virtual machines. We're gonna spin up a virtual machines. We're gonna have auto scaling and load balancers, and the aim is we're trying to emulate the real world instance of when an instance when I mean instance, I'm referring to virtual machine in this case. When an instance is overloaded and we need to spin up maybe a new instance in this case, or maybe when a specific region is done, maybe let's say US East 1 is done, and we need to spin up a new instance in East 2 using the same resources, that is already hosted on ES East 1. Sorry. So the whole overview is you have an application hosted in a specific region, let's say US East 1, and for some reasons, US East 1 is done. Maybe a natural disaster, maybe there's an fire outburst, in the data center. So we want to be able to have our application up there for our customer so it doesn't go down. So if this is done for some reason, we want to switch to the availability zone, which is another maybe US East 2, or maybe another availability zone that is functioning. So that is the whole aim of this stream, right? So also, while doing that, we take a look at DNS mapping, IP addresses, what these things are. I mean, literally, DNS is like domain name system, right? It's literally like your house address. So if someone wants to visit you, you give them your house address. That's simply what it is. And behind it is a unique, IP. So every machine, like where you are right now, there's an IP address from the machine you are connected to. So these are like a unique registrar. So the same thing happens when it comes to domain name. So when you visit, let's say, Amazon.com, Google.com, Spotify.com, the domain name behind it has a unique IP address that is being used to identify. Though we are not going to dive in more into it, like in the practical perspective, like having a custom domain using RAT3. We're not going to dive into that, like using RAT F3 services, and so we're not going to dive into that in details. Yeah, because I think those services is not free. They're not on free trial. You have to pay for that. So we're not going to dive into that throughout this stream. So we just keep it, very simple and easy. We're also not going to dive into TSA a little bit. It's all about protocols, how your data have been transmitted to make sure they're secured and encrypted. So we're also not going to dive into that more, because that also have to do with using the RAT F3 service and so forth. So we're not going to dive into that also. But we see how it looks like on a user, like on a real world simulation of what this looks like. So we have load balancers, which we're going to talk about, and literally what they do, we're going to create one literally. But what load balancers is think about load balancers like your traffic cops, that decide when you should come and when you should not come. they're controlling the traffic, when this car should stop, when this car should come. So that also like an overview of what it does in infrastructure. So it knows when something should spin up and when something should not spin up. Right? Okay, this is done. Okay, this can spin up. This cannot be deleted, and so forth. Okay, so it just manages incoming traffic and distributes requests evenly across servers, to show that everything is working as expected. And we have the auto scaling. Auto scaling ensures optimal performance by adjusting resources automatically. So auto scaling is literally what helps us either uh, expand or shrink, right? So we can actually tell it what to do when specific things happen. So let's say we spin up a machine that is housing, let's say we spin up a machine that has a database of, let's say, 1 gigabyte. And what happens when that 1 gigabyte is like, maybe we have more users, more traffic, and it's almost full? Auto scaling, helps to spin up additional memory that can house the incoming traffic. Or also, what happens when nothing is happening? Like we don't want to waste money. We don't want to waste money. Though the whole aim of autoscale is to help you to manage money as well, right? So because the more you spin up more infrastructures, the more money you're paying. So if there is need to spin up, then spin up. If there is no need, then shrink. That's the whole essence of autoscaling. It just manages the infrastructure so that it knows when to spin something up, it knows when to expand, and it knows when to shrink. At any point in this stream, if you have questions, you can just go ahead and ask me on the comment section, and I'll pause and I'll answer. So I'll have my chat right here. Like I'll always be looking at it whenever, like a few minutes. I'll just take a look just in case there's a question or any difficulties anyone will be having. They will try to understand what cold starts are in cloud. And in simple terms, this cold start is literally, the time it takes that a machine to spin up. So let's say this machine is done, but we actually have like a load balancer and auto scaling that spins up another one immediately if something happens to this one. So the time it takes, that's seconds or minutes it takes for this other backup to come up. It's like when you have a backup power in your house. So when the main source goes off, the time it takes the backup power to come up is like what we call a cold start. So yeah, that's literally what cold start is. So the whole essence is making sure that we build a system that does not take so much time to back up. So if something happens, that could be, you can visit a site and for a few seconds it's not working because maybe there's a push going on, like there's a new update going on. That is why sometimes you see most of your favorite applications, they will notify you that there's going to be like an update during this specific period of time. So if you're using the platform at that time, you may experience some issues. So that's a cold start, depending on what kind of updates is going behind the scene. But the time it takes for the software or the platform to recover and start working at its minimum performance, that's what we mean by cold start. So the whole essence is to build so that it doesn't waste a lot of time when trying to get your users to start using the platform again. Okay, and lastly is like observability in the cloud. This is simply a lot. What it means is simply a place where you can monitor what is happening, a place where you can see what is going on. And in the live stream, I mentioned about observability as well, and I mentioned that most people, which is a very bad thing to do, like it's a very bad practice. Most people just focus on monitoring when things go wrong, and I always advise you monitor when things also go good, right? Monitor both, like monitor when things are bad, monitor when things are good. That's the best way to. That's actually the best way to implement observability in your infrastructure and your application. Monitor both. Monitor when things are good, when things are bad. It gives you yeah, what's I have a question. What's my your what's your go-to observability tool? I use what's it called? Prometheus. Prometheus. I've tried Grafana, okay, but yeah, Prometheus so far. That's like the two I've worked with a lot. So I use Prometheus most of the time. Yeah, but we'll be using CloudWatch for this. Yeah, CloudWatch is like it's not an external tool. It's like inbuilt right here. But I have worked with Prometheus a lot. There's Grafana too, but yeah, I work with Prometheus a lot, and yeah, you can literally configure every single thing inside, so that's like more of custom. That whatever happens, it sends you email, SMS, Slack message, and so forth. We'll be using CloudWatch for this demo. So we also see, where you keep track of the logs and stuff. So again, monitor everything that happens. That is the best way to monitor. Yeah, Prometheus and Grafana together, or Prometheus alone. I thought one logs and the other visualize. Yeah, Grafana actually helps you visualize. Uh, yeah, like Grafana helps you visualize where you can put the whole logs and stuff. So like as I have used both together, but I also use Prometheus alone, like when there's actually no need for virtual representation. Okay, so that was like a quick snappy overview of the keywords and basically everything we'll be doing. So let's dive into. You're welcome. So let's dive into getting our hands dirty. And again, if you don't have an AWS account, uh, I think everybody should have an AWS account right now. So it's like been 30 minutes already since going through the slide. So I believe you should have signed up. But if you have not, and if you have any issue, also let me know. Okay. Just keep track of the charts here. And I'll go ahead and share my other screens. Give me 1 second, entire screen. And I'll be sharing screen 2. Okay, I believe the other screen is up. If it's not, let me know. But I believe it is. Oops, yeah, I removed that. Give me 1 sec. I have just signed up for AWS. It has so many services. Yes, it does. I think AWS have like, I don't know. I don't have the number, but they have a lot of services. They have a whole lot of services. 1 sec, right here. Okay, I think this should be on the screen now. So if you first time you sign up and log in, you should have a similar console like what I have on the screen. It could look different from what you have, but yeah, similar. I mean, you just have if you be using it, you just have overview of things you'll be using and cost and everything just right here on the screen. Like for the first time. I think it will look a little bit different, but you can add widgets and stuff, the way you want it to look like. Okay, so this is literally what the console looks like. So this is AWS console, and everything we'll be doing right now, we'll be doing on the console, right? But that is not the only way of doing this. Uh, you know, on in a production level, like in a startup, in a production application that people are using, most of the things are configured automatically. Using CI/CD and infrastructure as code tools, like Terraform and CloudFormation. And like everything is being automated. So like nobody's like logging into the virtual machine. Nobody's SSHing into the virtual machine to push code and stuff, right? So like in a real production world, most of the things we'll be doing is already configured automatically, so that it does that automatically, right? So like most of the things, some could be configured on the console, but most of the day-to-day is already configured through infrastructure as a code, just instructions that does exactly what it should do. But we'll be using the console to get our hands dirty on this. So the first thing we're going to do right here actually is create a resource group. Give me one sec. I just want to get that page up here again. So I believe you should have access to it. If you don't, pasting it again on the chat. So it gives you more like an instruction of every single thing we'll be doing today. Yeah, so again, this page, it gives access to everything we'll be doing today, and it also gives access to the snippets we'll be using, like the code snippet we'll be using also for this stream. So if you need that, just use the link. Just click on the link here. You have access to that. And also, this is instructions for what we'll be doing. It has an interactive map. Yeah, just an overview of literally what we'll be doing. So this is like the internet, right? And this is like how we're going to configure our infrastructure, to build a resilient infrastructure. We have a VPC, which is what we're going to create right now. And if you wonder what VPC is just like a folder. It's just like a folder. When you have folders in your laptop that has these specific informations. So maybe you have like finances folder, you have school project folders, you have music folders, document folders, and so forth. So you actually know you want to put all these resources inside this specific big folder. So that's what VPC is like. And we're going to use that because it will help us also when we want to clean up our resources. When you have a folder of school documents, or when you have a folder of whatever it is that you want to store, it's easy to locate, and it's also easy to get rid of, like delete it when you want to. So that is literally the whole essence of using resource groups. So we're going to create a resource group. That is the first thing we're going to do. I didn't put it right here on on the screen. It's not here, but yeah, think about it as it's going to be just over the VPC, right? So we're going to create that folder, and inside that folder we're going to have our VPC, which is like a container. Okay, so I think the explanation right here actually explains it. So this is like a giant fence around our private neighborhood. So think about it like a private estate. So like an estate, and there's people living in the estate, right? So all those people in the estate have access to the estate. So yeah, I'll use VPC as that. So inside the estate you have houses, or inside the neighborhood you have houses. Each of these houses could be whatever they are, maybe different resources. But yeah, so think about a folder as not an estate now. So VPC would be like the estates, and the resource group is just a Okay, let me. Yeah, resource group would be like a bigger example would be like a city, right? A city, but yeah, we can actually have. It's not like a city. Like I don't know. We can have a city, a community. Inside that community, let me use community as an example. As a community, inside this community, you can have estates or neighborhoods. Yeah, so like that folder, that biggest folder. So the community is just a tag. It's like a tag that we can use to identify. Oh, you're from here. Let me use states for example. Yeah, you're from these states. Inside these states, we can have neighborhoods, which is like VPCs. So let's create a resource group. So from your console, you can find services from the search bar. That's the easiest way to find services. You can also go through services using this also button right here, and you can find the service you're looking for, or you can just search for it from the search, right? So I'm looking for resource group. So I have a comment, Gemini link not working. Any other person have issue opening this link? What is it showing on your end, if I may ask? Any other person have an issue with this link? Let me know. It should open, like it's actually public. But if anyone is having issue with it, let me know. Let me try open it in incognito and see. It opens for me. It's first time you open it, it gives you a prompt. This app was created by another person. You just click continue, and it opens. I'm using incognito right now, and it's opening for me. So it should open on your end. If anyone else is having issue, let me know. But what are you seeing? What are you seeing on your end when you try to click the link? But it should open. It's actually public. And just in case it's not opening, I will just share the GitHub link also for the snippets right on the comment section. Just in case, for some reasons, that link is not opening for you, you can follow along with the with my screen, and you can use the GitHub repo for the snippets. Okay, so from the AWS console, just search for resource group right there. You'll see resource group and tag editor. So click on that. Yeah, so click on that, just create a resource group. Let's go ahead and create a resource group. Let's give it a name. Yeah, it's going to be a tag base. So the type should be a tag base. Resource group type. So this should be all supported AWS services. So just search for all supported. So we just want this resource group to have every supported AWS service. Not sure why it's not checking out. Why is this checked out? Yeah, I don't know why this is checked out, but it should allow me select that. I don't know why it's not, so I'm just gonna select each of them differently. Is it to actually wait? Oh, okay. Yeah, I've already checked this, so I'm literally selecting everything. My bad. Okay, so this is key tag. I'll call this project, and we'll give this a value. What should we call it? Let's call it J Global Hack Quick Deploy Demo. Any other thing we need to do? No. So tag base, key tag projects. The value should be, yeah, just something unique. Group name, we can still give it the same name. And we can give it a description if we want to. Not sure we want to give it a group tag. I think the tag here is enough. Okay, I think that's all we need to do here. We can just go ahead and create a group. How do you make the Gemini playbook? I just prompted it. That's this question. How did I make the Gemini playbook? Yeah, I prompted it. I think Gemini have a Canva option, so you just switch to Canva, switch to Canva. Is it Canva? Yeah, I think it's Canva. But if you switch to Canva, you give it instructions of what to do, everything you want it to do, and there's an option where you select how you want it to look like a site or something. Yeah, but yeah, the Canva. If there's time, I will show you exactly what I did at the end of the stream. Okay, so now we have our group created. So next is a VPC. So group is just a group, like I say, it's just a tag, like a states. Like I came from this state, so just a tag to have everything in one place. So at the end of the day, we should be able to come back here and we should be able to see everything inside this group or everything that has been tagged inside this group. So we can be easily locate it and delete or make changes if we want to. Okay, so back to the search bar. Next is to create our VPC, which is our neighborhood right now. So you can just type VPC on the search. One thing I forgot to say is so when deploying or building infrastructures in the clouds, all these things are physical data centers somewhere in the world. So make sure that if you want your resources should live on a specific region, right? Oh, that was the first thing we're supposed to do. Make sure we are setting up our region where we want all our resources to be. So I mean, we can have a specific resource that talk to each other in like two different regions. Like some services also are not available in some regions. So in case you're trying to use a service, you may see like a notification that this is not available in this region. So AWS have like a whole lot of data centers all over the world, which is like regions. So you can also always make sure you are in a specific region. Maybe the most reliable one, like example, US East one is more reliable. Like it has basically all the whole services. US East one is the region that have all the whole services. The AWS has this, I believe so. Yeah, it does. So it's always also the region that have most of the issues also. So like when AWS is down, it's always the US East one. Yeah. So I think like the more things you have, the more problematic it becomes. Anyway, so make sure you are in a region, basically closest to you, or in the region that have all the services you need. So these are like regions. So if you're working a product and it's just targeted to maybe people living in Europe, then I think you just host your stuff in Europe. Or maybe you're working with a client and they want their data to reside in Europe or maybe in Asia. So you just work with the region. It could be for data protection and all the rest of the policy. So they have a lot of regions that you can decide to host your applications and infrastructures where you want them to live. It could also be because you want them to be closer to where you are or where you have most of your customers as well. But again, some services are not available. Some services available in some regions are not available in some other regions. So always use this one. It's always like the most reliable, but when it fails, it becomes the most unreliable. So it happens, but it has like all the whole services you may need. So for this, I'm just gonna create a VPC, which is like our neighborhood in this case, and I want to do the manual stuff, like the bottom manual stuff. So I'm gonna create everything by myself. Like, so this gives you access to, you can literally spin up your VPC, subnet, and route tables, everything from here. But I'm not gonna do that. I'm gonna spin up only a VPC only. Right? And so I want to show you how you can actually do this manually, everything, and connect everything together. So I'll spin up a VPC only, and for the name tag, I cannot remember what we. Yeah, so this is basically where you should link our tag. What was the name we gave it again? I think Global Hack Week. No. Give me 1 second. VPC only. Give it a name tag. So I have these names pre-written already, so I don't make mistakes. Code is deploy demo VPC. For the CDA, keep this to 16. One second. Trying to remember what we gave. Yeah, I think we called it project. Yeah, remember. So project, and the value was deploy. No, what was the name? Yeah, I think it was deploy demo. Was it this? I believe it was. Yeah, I think that was the project and the tag value. Okay, so for our VPC name, we call it deploy demo VPC. I just copied the words. So I have these names pre-written. Just copy and paste the names right there. Okay, I just go ahead and click on create VPC. Okay, just a quick test. I just want to see if I go to my resource group, will I see this VPC right there? Oops, that's not what I was looking for. Okay. Have the resource group, but is there a VPC inside? I can't see one yet. Okay. But let's continue. I'll see. So we created our VPC, and which is our neighborhood. The next thing we need to do is we want to create our subnet. That should be the next step. Playbook view. We get a resource group created. We build the foundation, which is the networking aspect. So we're gonna create a resource group. Sorry, our subnet. After subnet, then we can create security groups. So we're going to create two resource groups. Create an internet gateway, click the routing before we create the security groups. Okay, so back to the console. Again, AWS console sometimes is just a little bit slow and laggy. It has been that way over the years. So this is a VPC we created right here. Yep. Okay, so let's create our two public subnets. So this literally we allow communication to the resources in our. I have a question. In our resources, sorry, in our VPC. So we have to leave all the default selected options when creating the VPC. Yes. So just the name. Just give it a name and a tag. That's all. Yeah, just a name and a tag. This was the VPC I created. Yeah, I'll just delete it and recreate it again. So VPC, create a VPC. So I was answering this question on the screen. So we have to leave all the default selected options when creating the VPC. Yeah, so let's leave the default selected options. Just give it a name, which I'll call it VPC demo VPC deploy. Just call it this demo deploy VPC. For the IP4, yeah, just the manual, and just give it the range of 16 right here. So 10.0.0.1/16. I think that should be here also. Yeah. Inscription, no encryption, tags. Not sure why I can't. What was the name again? I'm trying to see if I can add that resource, but not sure here. I'll just go ahead and create that. Okay, so once we have that, I think the next thing I want to do is create two subnets. So we're going to have two subnets. One will be a subnet that connects to, that will finally connect. So we're going to have two subnets, one that allows us to have access to the resources like public, and the other one that only connects to our load balancer, like internally. So from your VPC console, just right here, just click on subnet, and we'll just go ahead and create a new subnet. Select the VPC you just created. That should be demo VPC, deploy demo VPC. Okay, subnet 1 of 1. I'll give it a name. I'll call it public subnet A. That's what I'll call this. Availability zone, I want to use US East 1A. For this, yeah. So start 16, ending 24. So just copy that and paste right there. I want to add a new subnet, which will be the the second one. So I'll call this public subnet B. availability zone. I'll use US East 1B this time. I just copy this again. So I have the port, I have the CDAL block of 16 to 24. That should be all for here. So the VPC want to attach these subnets to the VPC we created earlier. And want this to be like in two different availability zones. So when it comes to availability zones, right? I mean, inside US East 1, like it's a region. So inside that region, you can actually have different data centers in the region. Like a region is like big region, so you can have different data centers in that region. So you have US East 1A, US East 1B, they're like different data centers in the same region. So you want one public address to focus to be on US East 1, the other to be on US East 1B. I think that's all for here. So we just need two subnets. And yeah, go ahead and create subnet. Overlaps with existing subnet. One second. Am I supposed to leave this empty? So see the address overlaps with existing subnet. Give me 1 second. Leave it at 20. Let's see. Hmm. Oh, give me 1 second. So the VPC, let me see, open this on a new tab. What is the block we provided for that? This is the one. Yeah, 16. That shouldn't be an issue. The city address overlaps with an existing subnet. Let me take a look at the existing subnets I have here. None of them is attached to the VPC we just created. So did I make a mistake? I think I did. No, I did not. Oh, I did. This should be 10.0 points. Let me see. So for the two public subnets, The CEDA should be 10.0.1.24. The other one should be 10.0.2/24. Okay, let's take a look at that again. Okay, that was my mistake. Okay, so now we have two subnets created. So what's next? We need to enable auto assign IP. We need to enable auto assign IP to the subnets so that it could be publicly accessible. So you should be able to actually access it publicly. Okay, so go to the subnet A, click on edit subnets. So do the same for subnet A. If you check the subnet A, click on action, you should see edit subnet settings, enable auto assign public IP4 address. Click on save. Do the same for public subnet B, action, edit subnet settings, enable the public, and enable auto assign public IP. Okay, so with that done, let me refresh. So just in case, just basically, if you're wondering what this does, it actually helps you to. So we're going to attach the security group, the VPC, the subnet to an virtual machine. So it will make it very accessible. Like if you want to access it from your browser, or if you want to access it from your terminal. So we literally make it public, give us a public IP4 address that we can use to access that. So with that created, I think the next thing we need to do is create a gateway interface. Where are you? Yeah, so we're going to create an internet gateway right here. You should see that right on the VPC console, internet gateway down here. Then click on create a gateway. We'll give it a name. Let's call it, I just want the whole name to be unique. So I'll call it deploy demo internet gateway. Tag name, create internet gateway. Let's go ahead. After you must have created this, click on action and attach the VPC. I mean, it gives you a notification. You can just do that directly from here. Attach a VPC. So the VPC we just created, which should be this deploy demo VPC. Attach the internet gateway. Okay, so with that set, what next? So we need to create a route table. So again, the gateway here is like it give your public subnet. Without the internet gateway, the public subnet cannot send traffic to the internet. So we need like a gateway for the public subnet to connect to the outside world. So now we need a public round table that can actually help round like the gateway to the destination we want it to be. So still from here, look for route tables just under the VPC. You see route tables right here? So we create a new route table, give it a name. Let's call it public route table. Attach the same VPC, demo deploy VPC, yeah. And create. After creating, you need to edit the route table. So click on edit route table route. Yeah, just to confirm. So route tables, Where's the one we just created right now? Right here, public route table. Just open that. Yeah, action, edit route, or you can just click edit route from here. Okay, so what do we want to do? We want to add a new route. So automatically to add the destination to the local and map it to CDN 16, we want to add a new route. This should be 0.00. Yeah, like a white card. So this is like a white card. We want it to be publicly accessible, not just to these ports. So you can just select the white card from here, like the 0.0.0/0. So this makes it available to, like, makes it available to the internet. So select internet gateway as the target. And what again? Where did this come from? 1 second. Internet gateway. Oops. Add the route table, white card. Our target is internet gateway. Automatically, it targets the internet gateway we created earlier. That's the deploy demo internet gateway. Attach it to it also. And click on save changes. Okay, so route table created. We attached the internet gateway to it right here. What next? So next thing we need to do is associate both subnets with the public route table also. Right here on the route table, click on subnet association. So this basically you're trying to say, we want to give it the public address, the subnet we want it to use when routing. So all you need to do is click, I think it's already attached right here, if I'm correct. Yeah, it is. Oh, no subnet association. You don't have any subnet association. So click on, oh, so these are the available ones. So we need to specifically attach it right here. So click on these subnet associations. Select both of them right here. So this is the public subnet A and public subnet B. Click on save associations. Okay, so if we come back here, we should see that right here. So with that in place, the next thing we need to do is go ahead and create our security guide, which is the security groups. I think we're done with creating resource group, VPCs, internet gateways, route tables, and attaching them. So the next step is to create a security guide, which is like creating a security group. Okay, so if you are wondering what security groups are, these are literally where we specify who can access these platforms and from where they can access it. Like is like a guide. It gives you access. We specifically say, give me access if we want, or we specifically tell it what to give access and what not to give access. And if you're wondering where this is used in real life, some applications are, when you host on applications, mostly we use microservices, right? Every application depends on some other services. So let's say you have your database hosted on a specific EC2, right? That EC2 will have automatically an IP address of it. And you have your application hosted somewhere else, and your application needs to communicate with the EC2, like to fetch data from the database. You only want the application to talk to the database. Like you don't want someone else, you don't want any other application to talk to it. So like it needs to be, basically you're trying to make it a very private security network where it's only this application that can talk to database. So you know that no, you can't bypass going through other means to talk to the database. Like you can talk to the database directly from your computer, from your terminal, All right. So you need to be only from the application. So you can like specifically say on the security group that you only want to give access to the IP address of where your application lives, which is like maybe an EC2 IP of where the application is hosted. So that's like what security groups literally, does here. We can literally use it to specify who and who should have access and which port they should have access to, right? From which port they should have access to. Okay, so back to our console. To create a security group, we need to go to the EC2 console. So you can just search for the EC2 back here. I already have it pinned here, so I'll just click on it. And we're going to create a security group. So look down here on the EC2 console. You should see under network and security, click on security groups. So we're going to create two security groups. The first security group we're going to create is our load balance security groups, the application load balance security group. That's the first one we're going to create right now. So create security group, give it a name. I'll call this ALB security group. That's application load balance security group. Again, the VPC, make sure you select the VPC we deployed earlier, which is the deploy demo VPC. Yeah. You can give the description, like what this security group does. And again, this just allows access to our ALB, which is application load balancer. Okay, so we have to define the inbound rules. We don't need any outbound rules, so we're only defining inbound rule. The inbound rule is like leave it at default, like is access to white card. So for the inbound rule, we need to listen to port 80, which would be an HTTP on secure right here. Where is it? HTTP. So that will like automatically select the protocol and range. For the source, I'm still going to use white card. Anywhere on IP4. So that will automatically give you a white card. I want to add another row to listing on HTTPS secured source. HTTPS, where are you? And I'll still use white card for this demo. Okay, so you can leave every other default. Again, this is for demo purpose, right? Depending on who should access this and who should not access this. So for a more private resources, you just have to specify from which location they could be accessed. So I'm using white card, which is like 0.00 is like white card, like can access from anywhere. I just want to make sure like everything we're doing here works. So create security group. One should be on the port 80, the other one port 44, 443, and give it white card. Then second one, create a security group for accessing. So one security group is for our for our application load balancer, while the second security group would be for our EC2. So how we can access our EC2. And the other one is how we can access like the Elastic, the application load balancer. I don't know why Elastic is in my mouth. So back to the EC2 console, hit create security group, and then create a new one. Back to security group. So we need two security groups. We already have this. We're gonna create a new one for our EC2. So I'll call it application EC2 security group. I just call allow SSH this to our EC2. Just a description, not necessary, is optional. Make sure the VPC is the VPC we created earlier, and then add inbound rule. So this should be SSH. So we want to be able to SSH, like communicate to this from terminal, log into it. Terminal. This IP I could set to my IP, right? But I'll still leave it at. So if you set it to my IP, it automatically dictates your location, your IP address, and log it right there as a destination. But I will leave it to wildcard. I don't know if I have VPN on. I doubt, but I'll leave it to wildcard so that when I try to log in, everything works. If I mean, you can still use it here as your IP. So if you use your IP to find your IP, so that means you can only SSH into this virtual machine, into the virtual machine only from your location, only from your IP address. So someone else cannot have access to it because if they're not on your machine, because your machine will have that specific unique IP address. So, but I'll leave it as wildcard for now so that I can access it from anywhere. That's for SSHing into it. And also, I want our application load balancer to be able to talk to the EC2. So I'll also give an inbound access to it. So this will be on HTTP protocol right here. And to be custom, and I want to look for the security group we created now, which is the LB security group. So literally want to give the application load balancer access to the EC2 to access the EC2. So the application load balancer can talk to the EC2. So it can talk to the EC2 just in case you want to do something to the EC2, like make changes or spin up a new one, copy the whole infrastructure of it. So we can just do that. So we need to give access to that as well. So leave everything as default and create. Okay, so with those two things in place, I think the next thing we need to do is spin up our virtual machine right now, which is creating the EC2. But before we create an EC2, we're going to create a role for CloudWatch. We're going to create an IAM role, Identity Access Management. We're going to attach that later on to it so that CloudWatch will also have access to monitor what is happening on the EC2. So back to the console, just before we go to create before we go to create the EC2, let's create an IAM role first. Yeah, this. So go to the IAM role from here, just search IAM. Yeah, the console is laggy. It's always laggy. The AWS console has never been fast before. I don't know why. So from the IAM role, just click on roles right here. Roles. We're gonna create a new role. So search for. We're going to attach an existing policy. Give me 1 second. Create a new role. This should be an AWS service. Yeah, so we have access to EC2 for the use case. Search for CloudWatch. Give me 1 second. Service or use case is required. Okay, so this should be EC2. The use case should be an EC2. This is where we want to attach this policy, this CloudWatch policy. Click on next and attach a policy. I think I have the policy name right here. So just copy the policy name, search for it, and select it. So just search for this. You should see it right here. CloudWatch Agent Server Policy. So select that. So just in case you're wondering what IAM roles are, basically IAM is Identity Access Management. Is literally like a key. Like when you open your door, you use a key to open your door to give you access to the entrance or to your house or to your room. That's like literally the same thing here. So we need a policy that we're going to use CloudWatch to watch what is happening on our instance. To do that, we actually need we integrate a policy that can allow CloudWatch talk to our EC2, which is our virtual machine. So click next, give it a name. Let's call it EC2 CloudWatch role. We already have a name. That is it for this. Okay. Yeah, I just put demo. I think this is the one I created earlier. So this allows EC2 instances to call all AWS services on your behalf. Click on create. Okay, so with that created, we can go ahead and spin up our virtual machine. So back to EC2. Back to EC2, click on launch instance right there. I'll give it a name. That's the name. It's the name server name right here. Give it a name. Call it demo. Deploy demo EC2. Do have additional tag. If we want to give that, we can give it a tag if we want to. Oops, 1 second. Yeah, so this is the name. Deploy demo EC2. Yeah, just one instance. Want to use an image. So image is like the operating system. So Amazon image, machine image, like what operating system you're trying to use in this case. Just stick to the one that have free trial. Just use the Amazon Linux. This will do for now. Then the image, yeah, just leave it at default, the free trial one. If it's not already checked, just make sure you're checking the free trial one. You can use the first option you see here. So this gives you, if it's a Linux kernel, so use a free trial so you don't get billed. Oops. Yeah, the console is a bit laggy. For the instant type also, you can use the T3 micro. These are like when you're buying a system, the RAM, the operating system, how many gigabytes of RAM, CPUs, GPUs that should be on it. So that's literally the instance type and the operating system right here, the architectures and so forth. So just make sure whatever you're choosing is a free trial so you don't get billed aside the free trial credit that have been given to you. Then for the key pair, create a new key pair, right? I already have one. Actually. Oh, I don't actually. So I'll go ahead and create a new one. I have to give it a name. I'll call it deploy demo key pair or deploy demo key. Or this is okay. I'll call it deploy demo. Actually, let me just leave it at deploy demo. I'll be doing all this from So usually we're going to be SSHing into our machine, and I'll be doing that from the terminal. And I don't need the PPK, but if yeah, we'll be using OpenSSH for that, for this, for logging into our machine if we want to. But if you're using Windows and you have like PuTTY, so you can actually choose the .ppk file. But for this demo, for this stream, I'll be using the .pim key. Create a key. It will ask you to download it. Immediately you click on it, you'll see your download. It's not showing on the screen, but yeah, you'll see your download icon come up. So you can go ahead and save that, which I'll do. Give me 1 second. I will save it to a location I want it to be. Okay, so I have done that. So save it. If you don't save it, you usually will not have access to it after this screen. So once you have that done, for security group under the network, VPC, you want to make sure, click on edit, you want to make sure we are attaching the VPC we created earlier. So for the VPC, select the deploy demo VPC we created before now. Just before I continue, 1 second, let me take a look at the schedule. I mean, this stream is supposed to end right now. I just want to make sure the next stream is not overlapping. 1 sec. Okay, I think it could. 1 second. Yes, so we should have a stream happening right now. So I have to give room for that. But yeah, on your own, you can go ahead and complete, use the instructions I shared earlier to complete the rest of the demo. Okay. And if you run into issues, just let me know on Discord, and I will be right here to answer any questions you may have. But yeah, follow the instructions, and you have access to this web page that should help you finish it up. And I have dropped a link to give us feedback on this stream and overall how the Global Hack Week Cloud has been going so far. Okay, so on your own, finish up the rest of the demo, follow the instructions on this page, and if you run into any issues at all, just let me know on Discord, and I will be there to answer your questions. Okay, just for the next stream, we'll be leaving now so that you can catch up with that. Thank you, and catch you later. Yeah, bye-bye.